In this section, we'll talk about translate, rotate, and scale. When we first started using Maya, including for modeling or animation, I'm sure we all learned something about this. But in this lesson, we'll explore translate, rotate, and scale from a deeper perspective. In the previous section, we talked about parent relationship. When discussing that, we mentioned the key concept: a child object's directions is based on its parent object. So let's review it here once again. First, let's draw a world coordinate system. Since this is 2D, we'll just draw the y and x axis. Then, in this scene, we'll create an object. We'll use a small box to represent it. This is just like the car we mentioned in the previous lesson. We'll also define its coordinate system. As before, the front of the car is the x-axis, and the roof is the y-axis. Then inside this small blue box, we'll put a child object. We'll use a small purple sphere as the child object. This represents the character sitting inside the car from the last section. Alright, now let's take this blue box in the scene and perform translation and rotation operations on it. First, we move it over here and rotate it at the same time. It now looks like this. We move it by a certain distance and rotated it about 45 degrees. Accordingly, its roof direction and its forward-facing direction have both changed. So now its y-axis should be in this position, and the x-axis is in this position. Now let's look at the small sphere inside. From what we learned in the last section, we know that the child objects translate, rotate, and scale values in the channel box are all relative to the parent object. So if we want to take the purple sphere and move it along the x-axis by say 5 units, pay close attention to the direction here. Because the sphere's coordinate system is based on its parent object, if we move it 5 units along the x-axis, or 10 units, then this direction must be consistent with the x-axis defined by our parent object. So moving along the x-axis now, its direction should be 10 units along this direction. Let's compare here. In our world coordinate system, the x-axis is this direction, but ours is now at an angle. This is what we mean when we say a child object's coordinate system is defined by its parent. So keeping this in mind, let's check translate, rotate, and scale again. In the channel box, we have translate, rotate, and scale. Now pay attention here. These three also have a parent relationship among themselves. How exactly is it defined? Translate is the parent of rotate, and rotate is the parent of scale. So if we look at the hierarchy of these three, it should be translate at the very top, then rotate, and then scale. So when we move an object to another position, because rotate is the child of translate, our rotation's pivot point will start from this new position, and no longer from the original position. And as we continue to rotate this model, we rotate it by a certain angle. Then our scale will all be based on the coordinate system defined by our rotation. Since we've rotated it, we know that our y-axis is pointing this way, and the x-axis is pointing this way. So next, if we scale along the x-axis, note that its scaling direction must be this direction. And if we scale along the y-axis, it also scales in this direction. Let's go back to Maya now and verify these theories we just discussed. First, let's look at my current Maya. I've created a simple hierarchy here. This hierarchy is actually just a simple demonstration of the relationship between translate, rotate, and scale. We can see that translate is at the top level. When we move it, it brings the lower level rotate and scale to the corresponding position. Then, when we rotate it, we can see that scale rotates along with rotate. So if we rotate it to a random angle, say like this, we know from the colors here that our y-axis is pointing this way and x is pointing this way. So when we switch to the next layer to scale, we will see that our x-axis handle points in the direction of that color, and the y-axis is this direction. When we scale it, we also see that only the x-axis scale value changes. If we change the y-axis, only the y-axis value changes here as well. So as we can see here, just as we mentioned at the beginning of this section, the child object's coordinate system is defined by the parent object. So our scale coordinate system here is defined entirely by rotate. Let's continue. Right now in my scene, I have this coordinate system model. It has translate, rotate, and scale. So let's see how they actually operate in Maya. When we translate it, we'll see when we switch to rotate. The pivot point for rotation is at this new position after we moved. And after we rotate it, if we then switch to scale, we'll see the scale coordinate system is identical to the one we just defined with rotate. And when we scale along a single axis, we'll see that only this one axis value has changed. There are no value changes on the other axis. This is what we were talking about. The relationships between translate, rotate, and scale are parent relationships. Now another thing I want you to pay attention to is this. When I rotate it now, for example, let's do a simple negative 45-degree rotation on the x-axis. Now if I want to translate it, we'll see my translate manipulator is now at an angle. At this point, when I move it along the y-axis, I want you to pay attention to the value changes in our channel box. When I move it along the y-axis, we'll see that even though I'm only moving one axis on my manipulator in my channel box, we'll see that values on two axes are changing. So why is this? We've actually already talked about the principle behind this. Recall the parent relationship we just discussed. Translate is the parent of rotate, and rotate is the child of translate. We also know that a child's coordinate system is defined by its parent. The reason we have this rotation is because of the movement of our child object. It has nothing to do with our parent layer. So no matter how we rotate it, it will not affect its own parent, which is its translate. And what coordinate system does translate reference? It should be the parent of translate. In this case, the parent of translate is the world. So it still aligns with the world coordinates. At this point, if I change the translate y to 10, we will see that it actually still moves straight up vertically. Now, some of you might ask, why does our manipulator show this angled orientation? The reason Maya chose this method is mostly for convenience when modeling or animating. It's not how Maya actually operates. If we want to set our translate manipulator to Maya's actual operation mode, we can change that. We can find these tool settings in the upper right corner. There's something here called axis orientation. Right now, it's set to object. If we open the drop-down menu, we'll see it has many options. There's world, which aligns with the world. And one of them is called parent, which aligns with the parent's coordinate system. This is Maya's actual operation mode. If we want to use a hotkey to switch it, we can actually press and hold the W key on our keyboard and the left click. Here we will see world and object. If we move the mouse over object and release, we go back to the mode we had before. If we want to switch to Maya's mode of referencing the parent, we can press W, then left click, go into axis and change it to parent. Now it's aligned with the parent's coordinate system. So based on this knowledge, let's look at an example. I have a slope in my scene. And on the slope, there's this object. We need to make this object move along this slope. We can see I've already set it up here. My object has a 45-degree rotation and is moving along this slope. But just as we demonstrated, when we move along this axis, we get value changes on two axes in our channel box. This is very inconvenient for animators, because for such a simple action, they need to adjust more attributes to achieve this result. And when they animate something more complex, this will just make it more and more difficult for them. So as riggers, we must also pay attention. If the animation can be achieved with one attribute, unless there's a special reason, you must not add extra attributes. Doing so will increase the animator's workload and also make their work more complicated and more difficult. Okay, let's get back on topic. How do we solve this problem? We just mentioned that because rotate is the child of translate, no matter how we rotate, we won't affect the coordinate system of translate itself. So in this situation, what do we need to do? We need to change translate's coordinate system. We know an object's coordinate system is defined by its parent. Right now, the parent of translate is the world. So what do we need to change? We definitely can't change the world's coordinate system. But what we can do is add another parent on top of translate. By changing this parent's coordinate system, we can change the orientation of our translate's coordinate system. So you can follow along with me here. Let's select our object and press Ctrl+G on the keyboard. Those familiar with basic Maya operations like modeling will know Ctrl+G is for group. We can also find it under Edit, Group, Ctrl+G. So now we've created a group. What we need to do is change this group's coordinate system so that it affects our object's translate coordinate system. So here we'll rotate it by -45 degrees. But of course, now our object is in a weird position. That's because we had rotated by 45 degrees before. Let's zero out this 45 degrees. This way, we've effectively passed that 45 degrees up to our parent layer. Now take a look. Our object itself, because it's a child of this group 1, and our group 1 has been rotated, we know that this includes its scale, and this object in the next layer down are all its children. So all their coordinate systems will reference it. So now, when we move along this axis, we will see that only the translate z value changes. This concept, this method, is something we will use again and again, including, for example, when we create controllers or want to extract a value from a specific direction, we will all use this method. I'm sure as we continue to practice, we'll get more familiar with it and deepen your understanding of this topic.